So hello and welcome to the continued coverage of the ongoing walkthrough series. And in this episode, you're going to be looking at the May-June of 2025 9618 variant 42. So let's go on and look at the questions right here. So for this paper, we were given 3 text files that we'll be using, and I think we are using the first two, that is stakedata.txt and second stake.txt for the first question. Then the hash data is going to be used for the second question. Then of course there's the instructions of how you're supposed to save your evidence document. Then they're just telling us about the three source files, two that are going to be used for the first question, and the hash data that's going to be used for the second question, as it were. So it says here that a program reads data from a text file and stores it in a stack. The stack is called stack, right? It's going to is stored as a 1D array of up to 20 elements. The pointer top of stack stores the index of the last element stored in the stack. Then item A here says that we should have a global array called stack that will have all the elements initialized to -1. Notice how -1 is in double quotes there, so it means that -1 is going to be a string. And they also specify that it's an array of strings here, so yeah, I think that's okay. Then there's also a global variable called top of stack, and that's going to be initialized to -1. So our task is to write a program code to declare and initialize stack and top of stack. So let's go ahead and look at the implementation that I have going on here. So here we have the class that's holding all the code, and then of course on lines 9 and 10, we are declaring and initializing the values to the specified, declaring and initializing the variables to the specified values, as it were. Then, let's out of the console, the console tab. Okay, so you see that here we have an array that should be initialized to -1. So there's actually a couple ways you can go about this. You can actually take the initialization into the main program, so that when your program runs initially, all the elements inside of the stack are initialized to -1, right? That's one way of doing it. And later on, you see that this is the way they were suggesting that you go about it. When you get to part F, you see that they say here that you need to extend the main program, is it? So basically, the initialization is supposed to happen in the main program, or rather, since I said there's going to be more than one way of doing it. They assume that you're going to do it inside of the main method. But my approach here was to use something called a static initializer in Java. So a static initializer is nothing but just a pair of opening and closing of braces, right? With static keywords. So you can actually see it here on lines 11 to 15. So the way you do it, it's called a static initializer because you have a static variable that you want to initialize to a given value, is it? And you just want to do it before during compilation, not during runtime. Because when you do it inside of main, it's going to happen at runtime. But when you do it as a static initializer, it's going to happen at compile time. So when the program compiles, I want to make sure that all my values inside of the stack array have a value of -1. So the way I went about it was to make use of this static initializer. Again, this is a very important concept that you should know should you ever come across such a question in the future. So for that, you are going to get 2 marks. So of course, you'd go ahead and copy this code and paste it inside of your evidence document. Then moving on to B, it says here that the function push takes a string parameter and attempts to store it on the stack. Then the function returns -1 if the stack is full, and the function returns 1 if the parameter is successfully pushed onto the stack. Then write program code for push. I have a video that I've done. It's here on my channel where I go about explaining the various data structures that you need to know for this course, as well as some of the algorithms that you need to know. And I also go into detail demonstrating the key operations with which you can perform on a particular data structure. And pushing is one of those operations that you need to know. So let's go ahead and look at the code right here. So we're told that takes a string parameter and attempts to store it on the stack. So you see that we have string data, that's the parameter right there. And since it's going to return -1 or 1, it means that the return type is going to be int. So you see that we have specified the variable, the return type to be int right here. Then we are simply checking to see if the top of the stack is not equal to the length of the stack, then returning -1. Otherwise, if they are not equal, it means you're going to execute this code and return 1 as it were. So of course, you'd go ahead and copy this code and paste it inside of your evidence document. Next up, we have part C, which says that we should create a function called pop that returns the next item from the stack. The function returns -1 if the stack is empty. Then we need to write program code for the function pop. So let's go ahead and look at the implementation that I have going on here. So we have the function pop. Then if the top of the stack is equal to -1, it means that we can simply not pop anything off the stack. So we simply return -1. Otherwise, we are just going to take the current value that is at the top of the stack and then decrement top of stack by 1 because we have removed the value that was on the top of the stack as it were. So you would of course copy this code and paste it inside of the evidence document. Next up, we have part D. It says that the text file stack data.txt stores numbers and mathematical operators. Let's actually go ahead and look at it here in the File Explorer. So I moved my file stack data.txt to the root directory, to the working directory of my project. So here's the file. You actually see all of these entries, right? Then let me just close out of the File Explorer there. So these are the math operators that are inside of the file, and you can actually see them here. Then, so the procedure that we are supposed to write in this case, we are supposed to write a procedure that takes a string, file name as a parameter, opens the file and reads in each line of data, uses the push function to insert each line of data onto the stack, outputs stack full if any data cannot be stored on the stack because the stack is full. Remember, our stack is a maximum size of 20, so yeah, eventually it's going to run out of space. And it also uses exception handling when opening and reading files, reading from the text file as it were. Just close out of the text, stack data.txt. So here's the read data function spanning from lines 35 to lines 48. So the return type is void because this function doesn't return anything. If you look here, we are not supposed to return anything, so it's a void function as it were. So that's why we have the void keyword going on there. Then we are taking the file name as a parameter. Then we are using the buffered reader as well as the file reader classes by creating a file reader object and a buffer reader object, which we are going to make use of right here inside of the while loop. So we are starting with an empty line. Then we are saying if we're now reading the line as it were. Then if it is not now, we are simply going to push that line inside of what? We are going to store that value inside of result here. Then if result is -1, it simply means that the stack is full. Otherwise, you're just simply going to break out of the loop as it were. Then of course, you're using exception handling right here, and we are using the IO exception class. Let me mention that this is the class that you should always use whenever you're dealing with files to handle exception, because there could be an input or output error when you're trying to handle your file. Then there's also the file not found class, right? You can also make use of that. But for this particular instance, we were told that when opening and reading the file, so it makes sense to make use of IO file, is it? IO exception class rather. Then of course you'd go ahead and copy this code and paste it inside of the evidence document. Moving on to part E, we have the values stored in the stack are used to perform mathematical operations. A total is initialized to the first value in the stack, and the first value in the stack will always be a number. The next value will be a mathematical operator, and the next value will be the number to apply the calculation to. So basically, they are just repeating the structure of our file right here. If I come and open the file here, you see that we have a number, an operator, a number, operator, number, operator. That's what they are just describing here. So our task is to first initialize the first. If you come here, you see that they said a total is initialized with the first value in the stack, and the first value is always going to be a number, is it? So we initialize the total to 10, then we take the next two values, so it's going to be an operator and a number. Then the next two values, so we evaluate that, then we take the next two numbers, another next two values, is it, and so forth and so on. So this is what we are supposed to do. The name of the function is going to be called calculate. So calculate is going to take each value from the stack, calculate and return the final total, right? So there's 7 marks for this one. So you need to do a lot of some planning before you actually just start writing the code, is it? So let's go ahead and look at the function that I have going on here. So we are using the function here, I think it's quite straightforward. Then we are initializing total, a variable called total. And what you're simply doing is we are taking, you're using the pop function to remove the current, the topmost element inside of our stake. And we are using parseInt to convert it into an integer. And we're also using the wrapper class. Then after conversion, we are storing that as the total. Then while the top of the stake is not equal to -1, right, we are going to pop the operator from what? From the stake. Now remember this, the value that we are now popping is now an operator because we did pop the first element here. So the first element was a number. Now the second element we are popping is now an operator. Then we are also going to pop the third element, which is a number. Then we are going to take check to see if the operator is what? Is a plus, a minus, a multiplication, a division, or a exponentiation, as it were. So in whatever the case may be, you see that we are just handling the what? The situation appropriately, is it? So remember the notation plus equal simply means it's the same as saying total. Let me actually just come here. It's the same as saying total is equal to total plus num. So this is actually the same thing. I will actually do this, or I will actually just do that. So it used the same result as it were. But I just prefer the shorthand notation, so I'm just going to remove this and maybe just comment it out so that you can always make reference to it. So we are just handling the appropriate situation in each case. Then for the, maybe let me just comment out for the power or the exponent. We are using the math operator, the math class rather, and we're using the power function. You can always check out my Java tutorials, my Java series. Where I think there's an episode in which I covered the math class in a bit more detail. So that's what we're just doing here. Then eventually we are just going to return the total after doing the calculation. Then yeah, we move on to part F. It says here that write program code to extend the main program. Again, remember what I said about when they said extend the main program here, they are assuming that you might have initialized your array inside your stake array inside of the main method. But in my case, I didn't do that because I used a static initializer. So take a file name as input from the user, call read data with input file name, call calculate, output the final total. Then we should get 2 marks for this. So let's actually go ahead and do that. We are using we're creating a scanner object, prompting the user to enter a file name, then using the scanner object to take the next input from the user, then calling the read file method. Then after reading the file, we are going to call the calculate method and storing the result. Then we output the result is it. Then eventually we are concluding by closing the scanner object to avoid any resource leakage. Then yeah, this line right here, earlier on when I was working on the solution, when I tried to, let me show you my project structure, you see that I had the stake data file right here. So when I tried to run the program, it was actually telling me that the file cannot be found, is it? So this line, it's important for you to know this line in the event that you might want to debug your program in an exam situation. So in the event that you cannot find your file, is it, you might want to print the current working directory. So it's just printing the current working directory by using the get property method that is found inside of the system class, is it? So it now told me where what my current working directory is, which led me now to copy this stake data text file and store it inside of the root directory here. So you see that this CIE CS paper 4 walkthroughs is the root directory. Then all the other subfolders that you are seeing here are subfolders, as it will, are not the parent directory. So that's why I had to move the stake data file right here. So it's a good line to remember whenever you want to debug your code. If you are working with files and the file cannot be read by your program. So I'm just going to comment it out because I no longer need it. So let's go ahead and move on to the next. Of course, you have to copy this code and paste it inside of the evidence document. Now we should test our program twice with the file name stake data and second stake.txt. So let's come back to the program, to the program here. Open up the console. And I'm just going to cycle through the commands here because I once ran it earlier when I was testing. So you have stake data .txt. So you see that the final total is 131, right? Then we are going to go run the program one more time, and this time we're going to use second. Well, it's second stake, I think. .txt. Then we are going to get final total is 320. Then of course you'd have to copy these outputs and store them inside of your and save them rather inside of your evidence document, as it were. So yeah, I think that's just about it for this video, for this episode rather. Hope you learned something, and I'll see you in the next one.